Problem 90. Find the first two derivatives of y with respect to x, given this implicit relation, xy equals x squared minus y squared. So the first thing to do is take the derivative of both sides of this equation with respect to x. On the left-hand side, x is being multiplied by y, so we use the product rule. The first times the derivative of the second, plus the second times the derivative of the first. On the right-hand side of the equation, we take the derivative by the power rule to get 2x. We take the derivative of this y term and we have 2y dy dx. Now that we've differentiated, we want to solve this equation for dy dx. To do that, we'll move all the dy dx terms to the left-hand side of the equation. So we'll keep this x dy dx, and we'll also move this negative 2y dy dx to the left. So plus 2y dy dx. And on the right-hand side, we'll move all of the non-dy dx terms. So we've got 2x minus y. Now everything on the left-hand side of the equation has a dy dx in common. We factor that out, we're left with x plus 2y. And the right-hand side stays the same. Now we can finally divide to solve for dy dx. So dy dx is 2x minus y over x plus 2y. So this is our first derivative. Now we're going to differentiate this again to get the second derivative of y with respect to x. So this says the second derivative of y with respect to x is, now the right-hand side we're going to have to use a quotient rule. So we square the denominator, x plus 2y squared. Now we've got the bottom, which is x plus 2y, times the derivative of the top, 2 minus dy dx, minus the top times the derivative of the bottom. So 2x minus y times 1 plus 2 dy dx. Now this looks kind of messy because we have a mix of x's and y's and dy dx's. So I want to get rid of all the dy dx's by replacing them with what we'd already found to be dy dx. So that says our second derivative is now x plus 2y times 2 minus dy dx, which is now 2x minus y over x plus 2y, minus 2x minus y times 1 plus 2 times dy dx, which we'd found to be 2x minus y over x plus 2y. And this is still all divided by x plus 2y squared. Now I don't want to deal with a double-decker fraction, so I want to get rid of these denominators. And we're going to do that by multiplying numerator and denominator by x plus 2y. So if we do that, in our numerator, we now have x plus 2y. We're going to distribute this x plus 2y to both terms of these parentheses. So this gives us x, 2 times x plus 2y, minus, now here the x plus 2y will cancel with the x plus 2y we're multiplying. So it gives us 2x minus y. On our second term, we have 2x minus y outside the parentheses. And now inside we'll do the same. We'll distribute this x plus 2y to both terms. So here we've got x plus 2y. And in the brackets here, the x plus 2y's cancel, leaving us 2 times 2x minus y. And this is still being divided by x plus 2y squared. Now in these parentheses we can distribute stuff through. So this says that our second derivative now is x plus 2y times, well, if we distribute this through, this gives us 2x plus 4y for this first term minus 2x plus y. So we can see that the 2x and the 2x cancel, and we're just left with 5y inside those parentheses. This other part will do the same thing. We've got x plus 2y. If we distribute this 2 through, this is plus 4x minus 2y. So just like with the other part, the 2y and the negative 2y cancel. So we've got minus 2x minus y times, combining these together, 5x, still divided by x plus 2y cubed. We now distribute this through, so we've got now our second derivative is 5xy plus 10y squared minus 10x squared plus 5xy. And this is all divided by x plus 2y cubed. We can go one more step in simplifying this. I see we have 5xy plus 5xy is 10xy. We have 10y squared minus 10x squared. So 10y squared minus 10x squared. All divided by x plus 2y to the third. And then finally, we can replace this xy, because back according to the original function, xy is the same as x squared minus y squared. So we can write this as x squared minus y squared plus 10y squared minus 10x squared, all divided by x plus 2y cubed. Then finally distribute this 10 through, so we've got 10x squared minus 10y squared plus 10y squared minus 10x squared. This is all divided by x plus 2y cubed. And notice that everything in the numerator cancels. 10x squared, negative 10x squared cancel. And also negative 10y squared and positive 10y squared cancel. So this whole thing reduces to just 0. So our first derivative was 2x minus y over x plus 2y. Our second derivative was 0.